So welcome back, nerds. Looking at this, we're jumping right in, and we've been talking for a few minutes. Nobody smiled at that, so that's my bad. Going through here, very first thing, every single time. What do you think we should do? Let's write an equivalent form. We're going to factor this as much as we can, so it's easier to think about. Now, really, really important distinction. We are not changing anything. This is right here, my original form. Like, that's just where we started, and that's all fine and dandy. But what we're going to write here in just a second is a factored form. They are equivalent. They just look different. They're easier to think about depending on what we're doing. So let's try to factor this. And what color is factoring in your head, Desi? Okay. Blue. So let's factor this. Does the top factor? Is there a GCF? Nope. And it's just a degree 1. Nothing happens. The top just remains 5x plus 6. In the denominator, I'm going to do a little bit of scratch work here, but I am going to erase it, just so you guys know. So let me know if you don't want me to erase it. The scratch work, I need to factor this. And my hope is that, like, we're a little bit behind of where I'd like to be because we beat factoring just into the ground over and over. And my hope is that you guys are all like stellar factorers now, factorers. But I recognize it's been a while. Help me out here. I'm going to run through my whole list and try to remember how to factor. Step 1, what's always the first thing I check? We be careful. I don't want you to say find the greatest common factor. Change your language just a little bit there. Sorry, did I give you guys these? You'll see them. I'm going to hook you up. This is a pre-calc thing because a couple years ago there were some issues with factoring as well. I'm going to give you guys like the fancy, it kind of looks scary, but it is a factoring checklist. It does everything that we've done so far. Yep. Now, you don't get to use these on tests and stuff, but as far as something that might be helpful if you struggle with factoring to have in front of you, I think this is going to be crazy helpful. So, as we look through it, a lot of this binge, this is how I teach factoring. It's not necessarily the way that you learned, but if you have questions, we can sort it out. So just to kind of show you guys, we're going to take a side trip here. So this is the really ugly form, right? Polynomials, like whatever, it's ugly. But right here, we just jump right in. And I think that there's a different version that I've written this, but always, does it have a GCF? Like we check that constantly. Is it a binomial? And then if it is it the difference of squares? Here's the rule for difference of squares. Is it the difference of cubes? Here's the rule for both of them. Okay, here's the part that we worry more about. This one, forget about n right now. This just says, can it be written like a quadratic? So it was very brief. We only did a couple of them. You'll see more of these in pre-calc. But if I write this on the board, and I guess I'll write it here so we can see it. And there's a small distinction just so we're using this. If I write this, x to the 4th plus 2x squared plus 1, is that a quadratic? So be very careful. It's not a quadratic, not exactly, because it's a 4th degree, right? Quadratic should be squared. Could we write it like a quadratic, though? And do you remember when we did this? And we're not saying we have to do it, but do you remember when we did this and we said, look, it really is kind of like a quadratic? What we're seeing is this form. And I don't really care if it's actually quadratic as long as it's even, half, and none. Okay, so this order, it can change. Is it a perfect square? So remember, perfect squares, these are going to get uglier here. So if you don't like this and you want different examples, just come talk to me. I'll help you get different ones. If it's a perfect square, you can take the square root of the first and the second, and then you multiply them to get this. Is this a perfect square trinomial? Do you know the square root of x squared? Sorry, x squared. Do you know its square root? X, good. Do you know the square root of 18? Not perfect. Okay, so what's the next thing on our list? Is it a perfect square trinomial? PST, it says no. What's next on your list in front of you? Or from memory? Is it a leading coefficient of 1? So we have a shortcut. I need to multiply what and what? So be very careful. It's not x. It's not x squared either. 1, because there was 1 right here. 1 times 18. 18. I now need factors of 18 that do what? 6 and -3. They add up to -9. So 6 and negative 3 doesn't quite work. That works better. Negative 6 and negative 3. How do we use these magic numbers according to, and can you follow what this is doing? I guess they just do it here. 4 and 1 were our magic numbers here, right? If it's a 1, how does this factor then? So here's my example there. I'm going to come back here. X and one of those magic numbers, negative 6. And the other one is X, negative 3. Okay, your factoring cheat sheet, if this one is not sufficient or if it's too ugly, let me know. I can try to make a simpler one because this is what I gave pre-calc, but it's everything that we've seen. If that doesn't work, you use quadratic formula. And then if just by chance none of the other ones work, you might have to do this PQ thing. So this is just everything that we've done factoring. Cool. I have copies of this if you want them. I would use it on your homework and stuff if you're struggling with factoring. But let's come back to this one. Okay, this looks very different, right? Like, very different. What is this the form of? This is the original. This is my factored form. Now, we're not really lecturing because we're just doing this in the homework, but I just want to make sure that we have an important comment between these. These two things, they look different, but they are equivalent, which means they are the same. These are the same function. If I put this in Desmos or this in Desmos, I get the exact same graph out of it. Everything is the same, except this one's nicer to think about sometimes, and this one's nicer to think about in other situations. All right, a ton of review stuff just happened. Can I speed up a little bit, or am I going okay?
You're good.
I got a new, well, I was about to whip it, is what I was about to do. Oh, that's it. Hold on. There, what is it? Hella money? Yeah. Is that what I have? Hella money? Real quickly, I'm going to not record. What word? The word. Did I? Yeah. It's okay. I don't need that. All right. So check it out. We are continuing in here. These are the same. Now, the big part is this I legitimately think is the hard part of the problem. If you can do this, you should have confidence in yourself. We'll get practice with graphing, but if you can do these things, we're golden. So let's make sense of all this. There's no particular order that it has to happen in. Jade, but I want your help. I want you to help me find the vertical asymptotes. Are you going to look at the black original or the blue factored version to get the vertical asymptotes? Why? I can't see the zeros right here. Here I can. What values of x make me divide by 0? What makes this factor equal to x? And if it's not clear what I'm asking when I do that, when I say what value of x makes it 0, I'm really asking you to solve this equation without saying it. Yeah, 6. The vertical asymptotes are the zeros of the denominator, and notice I'm not calling them zeros for a very particular reason. Give me another one. Yell. Love it. How many vertical asymptotes do we have? 2 of them. Now, we're going to put on one last, nope, I lied with it. We're just going to roll with that. Cool. How about, this is the hard one. Okay, you'll have to check in your notes, but there's 3 possibilities, and I'm going to look at the original. Real quickly, I need to compare the degrees. It's my degree check is what I'm doing. What is the degree of my numerator? 1. It's the biggest what? The biggest exponent on the variable. So there's a 1 here. That's a 1. What's the biggest degree or the biggest exponent here? 2. Cool. So there it is. What's the degree of the numerator then?
1.
So degree, and I'm going to write this, degree of the numerator. And I'm just going to write the number underneath. And you don't have to do this every time, just so you know, but I'm trying to re-emphasize this. It was a 1.
Wait, why is the 1 on the bottom x squared?
Because it's what we were given. No other reason. Yep. Okay. And I want to compare this to the degree of the denominator, d. What's the degree of the denominator? Not 0. What's the biggest power of x in the denominator? X to the 2. Its degree is 2. That's how we find it. Now, in this situation, what's bigger, the denominator or numerator? If it's 1 and 2, it's the denominator. So I want you guys to check in your notes the other day. We wrote 3 possibilities. So Beatrice, just so you know, we're going to the notes. I appreciate that you're sharing. That's the right thing to do. But I'd rather you check the notes than pass out gum. What happens if the degree of the denominator is bigger? Check your notes. We're going to see, I'll turn the lights back on so you guys can read your notes. Are you guys in fisheries?
Yeah.
How are the eggs? No eyes yet? Look, I bet you'll get some eyes in the coming days. How many ATUs are you at?
How many, like what?
64.
You count all of them?
I would just fake the 3 weeks and say the water was 2 degrees the whole time, is what I would do. Yeah, fair. All right. What happens here if the degree of the denominator is bigger?
Degree. Denominator.
So don't guess. Where's your notes?
Oh, I thought you meant like which is bigger.
Yeah, we already decided that part. So I need your notes instead of homework. I agree with you, Benj, but I want to wait till people get there. So let's see the degrees. I see them right here. If the degree of the denominator is, so let's see, degree of n is bigger. Here's denominator is bigger, right? What's our horizontal asymptote? You might have been blank just as I looked at it. You need to put y equals 0. Oh, it's right here. That's it. Okay. So if the degree here, did you find it in your notes? No, you're good. Are these your notes on the other side?
Okay, we got a lot going on here.
No, you're good. I can already see it right here. If the degree of the denominator is bigger, which is this one, here's our horizontal asymptote. Y, so be more specific. Y equals 0. Now this one, I'm actually going to cross it off. You don't have to, but we don't normally do all this, but I'm going to start doing it. I lied. We'll just do it here. Implies horizontal asymptote at y equals 0. Okay, I normally don't write this part, but there's only 3 possibilities. It's good practice. What's the only other thing we need? We have VA, we have HA, and we are going to graph this one. We need the x-intercepts, and that feels blue to me. So let's do that. X-intercepts. The x-intercepts happen when which part is 0? The top, the numerator. Desi, if you set the numerator equal to 0, what do you get for x? And that's this equation. Yep. Try again. Step by step. What's the first thing you would do? There you go. And then you're going to divide by 5. So you are upside down, but here's the one thing I'm going to try to do consistently. This is an ordered pair. -6/5 is what I get to get what y value? 0. Now, I'm going to make one more little note here. How many times did this root just show up? Shows up once, which means it crosses through. So shows up an odd number of times. And this is all good review stuff, which is a multiplicity of odd, which just implies to me we cross the x-axis. Okay. We are working pretty slow through this. We will not go this slow through the next one, but where have I lost anybody? Or am I just going painfully slow and nobody's lost and just...
I don't think you're going slow. I just think sometimes when I'm writing stuff down, you're talking about the next thing. And
That's fair. Please feel free to interrupt me, okay? Like you can always interrupt me and I will just awkwardly hang out. Cool. Okay, if you can get to this part, there's one little thing where I would say put it on your note card. It's the degree stuff. Like I would have these degree rules on your note card tonight, just so you know. I'll let you use a note card tomorrow. Here's where we struggle. If you can get here, but you struggle with graphing it, I think you're struggling on the part that you shouldn't be. This is the hard part of these problems. Now let's logic it out. And it's really important. We're going to pick the same scale here, but we're going to make sure everybody's comfortable with the logic. And if you're not comfortable with it, you're going to do what? You're going to tell me. You're going to say, I don't get what's happening. I don't understand that. Can you explain that a different way? I can explain this stuff, I don't know how many different ways. A lot, I would assume. But we're going to make it click. If we can get here, the rest of it's easy. So let's look at stuff. Right now, I see that my y-axis, or my x-axis, is the asymptote, so I need to see it. And how far to the right do I need to go for any of these points? What's the most right value I have anywhere in here? The biggest x. 6. So I want to go a little bit past that. So I'll probably go like to 8 or 10 just on my scale. What's the most negative x value I ever need anywhere? Further left than 0. I need 6. I need 3. Where's my x-intercept?
-6.
So negative 1.2. So maybe I'll go to like -2 or -3, somewhere in there. The reason I'm thinking that out is that if I don't want to have to do like the big scale like this, because if I only have to go to here, it's pointless to have all this, right? So all I'm thinking out right now is, well, I need 6, 3, and -1/6, and y equals 0. So I'm going to focus everything over here where the bulk of my information is going to be. Now I need to go all the way out to at least 6. I'm going to always go a little further. What do you want me to jump by? I can jump by 4 or 2 or whatever. I'm going to go out to 8 is usually how I think about this, because I want to go a little bit past my asymptote. If this is 8, and I like that I don't have the graph paper anymore because you guys don't either. What's this, roughly? I think 4. Why 4, Beatrice? Yeah, I just eyeballed right in the middle. And then that means that this would be approximately what? So -3 is probably a better guess, but just based on it, because we're just sketching, would you believe it if I said it was -4?
Yeah.
And I can maybe even move it a little bit more, but I'm trying not to erase stuff. Now it looks at least kind of believable. Now I don't really know how high I have to go up on the y-axis. In fact, if we're sketching it, maybe I don't really care that much, because there's a difference between sketching, really rough idea, and graphing, really nice, perfect idea. Desmos does graphs. We're going to do sketches. Okay. In calculus, we graph them, but it's so much nicer than making big tables. How do I represent asymptotes? And I'm going to label these so I don't forget which one's which. Dashed lines. Now, I would encourage you guys, if you want colored pencils, I'll hook it up. Colored pencils will help. Like, you don't have to dash them as long as you can tell. Would you believe it if I said, here's 3? If I do this, you're definitely going to believe me. And x equals 6 would be right here.
Wait, why are you drawing it like that?
Because what happens at x equals 3 and x equals 6? So look through here and tell me what I just graphed on here.
Oh,
These are my asymptotes. So when you say, why are you graphing them like that? What do you mean like that, I guess?
well, I was just looking at before the 8 on the number line on the x.
Okay. Yep, I just use these to scale so that I can eyeball these out. Yep, we could have jumped 5 and 10 or 2, 4, 6. Like, I just picked a scale that I can see. Am I ever going to touch these? Never. Never, never, never. Now, what's weird about this is we also have a horizontal asymptote. And this one, I hate when it happens. But the only way that I can really represent this is if I just make it kind of bold on the axis. So I know that with pencils, this one's going to be like impossible. I always typically just draw them as dashes above it so it's clear, even if I'm just using black pencil. Am I ever going to touch this one?
Yeah.
I could. And in fact, I will. Horizontal asymptotes, they're different. They just tell me what's going on where. I mean, you're right, but they, like these tell me what's going on everywhere, my domain. These ones only tell me what's happening at the end. And that's the weird thing about it. Okay, let's see if we can't make sense of this. Any points that I can put on my graph?
-6/5.
So 1.2, and I'm just going to eyeball it. Would you agree that it's this? Seems believable. Now, there is an issue that I have with this, and like not really a terrible one, but notice something. And I'm going to make some comments. You can put them on your graph if you want. You don't normally do this, but I just want to really make sure we hit them hard. Are there any other x-intercepts? Or is this the only one we found?
Only one.
So quick comment here, and it's entirely up to you. Only place we ever touch the x-axis. Now I'm going to graph right through these words, and it's going to be ugly if you want a larger arrow. This is the only possible place that this will ever happen, ever. So it means that we have a decision to make. I can't tell which way my graph goes right now. I don't know if it curves downward or if it curves upward, but I know it does one of them. And it's okay, whichever one, because it just gets really close to this value. And it might do some wonky stuff. But if I wanted to plug in an x value into either version of my function to figure it out, is there an easy x value between this one and my next asymptote? People might have zoned out there for a second. Do we need a quick brain break here? Let's finish this problem. Give me like 3 more minutes. We're almost done with it, and then we'll do a brain break. Give me any easy value between -6/5 and my next weird spot that happens at negative or at 3. 0 is easy. 1 is easy. 0 is easier. If I want to know my function, it does 2 things, right? It either comes up like this or it comes down like this. Those are the only 2 options. If I knew that f of 0 was up here, I would know what it does. Okay, so let's just get a little bit of a couple extra points. If I wanted to find on my function f of 0, what does my function do at 0? I can plug into blue or black. Black or blue, doesn't matter. Which one do you want to plug into, Yale? Blue, sure. If I plug into 0 in for x, what's 5 times 0? Plus 6. So it's a positive 6 over, let's do it in the denominator, 0 minus 6 and 0 minus 3. So that'd be a -6 times a -3, which is 18. I plugged it in here, and I'll even go back further. F of 0 is -6 times -3, which is 6 over 18. Alternatively, check it out. You guys elected to plug it in here. That's okay. What if I plugged it in here? If I plug in a 0, I get 6 over 18. It's the same thing. I can plug into either of them, and I'm going to get the same value. We just decided that when x is 0, my y-intercept, is it positive or negative? Positive. And it's small, right? It's 6/18, but it is positive. The fact that it's positive just locked me in. If I know it's here, does our function curve up or down? Up. Now, we curve up, we don't cross the asymptote. Down here, it's going to be strange, but it crosses. I know it crosses. So it's going to cross a little bit, and then it's going to mellow back out at that asymptote, and it'll never touch again.
What's that second point?
This one?
The 6/18.
Yep, that is 0, 6/18. And I don't even care that it's 6/18, to be honest. When we did this earlier, because notice, I still haven't picked a y-scale. When I did it earlier, first hour, I don't care about the actual number. I only care whether it's positive or negative, because that's going to dictate whether it comes up like this or if it comes down like this. Does that make sense? Yeah. Okay. All right. For the middle section, we don't know what it does. Is it ever going to cross the x-axis again, though?
No.
The graph, just in general.
No.
It crossed here, which is the only place. We would have found more roots, right? More x-intercepts. It'll never cross again, which means for this middle section, we have 2 possibilities. It is either up like this, and it never touches the axis, because it has to stick between them, or it's down like this. I just need to decide which one. Well, let's figure out. If I want to know what my function spits out, I'm going to pick a value between 3 and 6. And I don't care what it is. We're just getting a couple extra values. 4. Okay, so let's try f of 4 real quick. And I'm picking values between these. That's how I'm choosing 4. I could have done 5 or 3.2. Doesn't matter. Do you want to plug into black or blue? I just heard noises. I didn't really hear anything specific. Blue? Let's plug into blue. Now, this time, I'm not going to actually get the number. I only care about the sign, because I just need to know above or happy parabola, sad parabola. So let's do it. F of 4. Don't care about the number. What's 5 times 4? Plus 6. Is it a positive 26 or a negative? Positive. Let's do the denominator. If I plug in a 4, what's 4 minus 6? So that'd be a -2 times, what's 4 minus 3? Positive 1. Now this winds up being, positive. Positive over a negative gives me negative. Now I don't know exactly where, right? I didn't get the value. All I know is that when I plug in x equals 4, I get a negative number. So I'm just going to guess. I don't know exactly where it is. Is that a negative value? So when I say, and thank you for that vocalization is what I really needed. If you don't know, it's super easy to work out. What do I mean by positive or negative? If I plug in x equals 4, we got a negative, which just means below the x-axis. Positive just means above, because these numbers are positive here and negative here. That's the connection that we're making. Why can't it do this? Convince me that this is wrong. We never found another x-intercept, right? It can't do that. So it can't smile. What's it got to do? It's got to frown. Now we're not, whoa. We don't know exactly what's happening with it. That's not our focus because we're just sketching. I can't erase that other one, not without doing this. But there's our middle section. Without getting any more points, we don't know for sure what's happening out here. I know it never touches. It could be here, or it could be here, right? One of those two. Pick an obnoxious point bigger than 6, anything bigger than 6 to get this. 7 would work, 10 would work. Would 100 work? Like, and 100, I know it seems silly, but that's one that I'm going to use. Because look at how easy this is. If I plug in 100 into the blue version, that's 506. Okay, positive and positive. Positive over positive. Means that all the way over here at 100, I'm above the x-axis. It's never going to cross the x-axis again. So it must be above the x-axis everywhere over here. Logically, did that connect? If I know that it's above the x-axis, and I'm going to hit that again because this is like the important part and where people struggle. If I know it's positive over here, even if it's just barely positive, and it never crosses again, it must be above the graph everywhere over here. That's the logic that I'm using. Now, I don't need to see all of that. I just checked it in my head with that point. It's positive or negative. So all I need is this graph that's positive over here, and it never crosses the axis. We did 2 extra points, and realistically, we didn't do any extra. Do you think our graph is pretty close to what it actually is? Do you want to compare, or do you believe me that it's pretty close? Okay, I'm curious out of it, and then we'll do a brain break. So somebody's going to have to read me the function here in just a second, though. Not YouTube. Weird. 5x plus 6. And the factored form was just x minus 6, x minus 3. Hey, is that what our graph did on the outside? And then what are we missing in the middle? Because I don't see it here. It's that sad parabola. There it is. It's exactly what our graph just did. It does right here.
Oh, no, the other one.
This one?
Yeah.
Never. And this one? Never. It gets close, but it never touches. Awesome. Okay. The graphing it, those of you that struggle with the graphing, does it feel okay? Okay, we'll do one more here in a moment that the factoring part I'm less concerned with. Quick question for you guys. That is 4 minutes, I believe. Yep. I'm pretty sure that one's 4. All right. On problems like these, left part over here, finding all this stuff, or right part, where's the more challenge? The graphing it? Okay, so for this, we're going to check a couple more. We were at 20. We just looked at 19. Just to go through real quick, we're going to graph a couple ugly ones here in just a moment. Oh my goodness. There it is. Okay, so looking at number 20. And if you want to keep your sheet of paper out, you can. Can you guys tell me where the vertical asymptotes are on number 20?
X equals 2 and negative 2.
Plus or minus 2. The 0 is the denominator. Where are the the horizontal asymptotes? Or asymptote?
0.
Y equals 0. Be specific with it, Jade. Degree 1 over degree 2, it's always going to be y equals 0 in that situation. Sorry? For the horizontal, it's y equals 0. For the vertical, it's plus or minus 2 on number 20. On 21, your vertical asymptotes are going to happen at plus or minus 1. Your horizontal asymptote is going to occur at y equals 5/2. Notice, notice, I'm not reading the answers, just so you know. I'm doing these in my head because what's the degree of the top? And squared, 2. And the degree of the bottom? 2 again. And if they're equal, it's just the ratio of this over this. Y equals 5/2. Done. Okay. For the graphs of these, we'll check them here in a second. These should be really quick and easy to make, I hope. But let's check. I want to look at one of these. 27 or 30, which one do you guys want to do? 27, deal. So you guys are going to help me graph it real quick. And realistically, you're just going to help me set it up, and then we'll take turns back and forth. So on number 27, here it is, last one. If you did it, awesome, we're checking it. If you didn't do it, less awesome, we're checking it. I don't know. X plus 4 divided by, and I need your guys' honest input. Do I need to factor the bottom part like out loud, or can I just factor it? Okay, so I'm just going to talk it through. It's initially it's over this 2x squared minus 9x minus 18.
Yeah.
Okay, now as I'm thinking this out, and I'm just going to keep the same color, the top doesn't factor. It's still x plus 4. The denominator, I'm trying to get better at factoring in my head, but I'm not putting a whole lot of effort into it outside of here. I see there's no GCF. I think it's going to be -6 and -3 is the numbers that'll work here. Just kidding. It's 9 and just kidding some more. It's 6 and 3. What? Do I have a sign wrong? Let me check here. I mixed two different problems. Time. I mixed two problems. What is the actual denominator? Minus 13x minus 7? 2x squared minus 13x minus 7. Yep. I mixed two problems just now in my head. In either case, if I have to factor this, it's not a leading coefficient of 1, so here's like all my scratch work, just in case. Is it 13? I need factors of -14 that add up to -13. 1 and 14, which one's negative? So I heard both. Why 14? So we can only use the shortcut, but we are going to factor it. We're just not going to use the shortcut. Negative because they have to add up to -13. Now, Benj, this might look a little different than what you've done. Factoring stuff feel okay to you? How do you write this one now that we've gotten this? Because there's no shortcut because that's a 2. So if I'm going to write it, and I want you to tell me if this is how you've done it, okay? I'm going to switch those numbers around. -14x plus x minus 7. Does this look like a way that you've done it before? Okay. Show me how you do it your way on your page, and I'll come take a look, okay? Okay. So in this, we use those numbers. Here they are. What factors out of here? 2 what? Good. Leaves behind x minus 7. What do I factor out of the other one to leave behind an x minus 7? Can't do that. What? Good. Now we have our factored form. And Deck, just to check in, how do you factor? Because I know before you were using only one method. Do you still only use one method, or do you kind of split them up?
Whatever is easiest for the problem.
How'd you factor this one? I guess you might not have done it. I don't know. I don't know if you did your homework.
Oh, grouping.
So same thing I did? Yeah. Okay. All right. I now have the original and the factored. Step 1. I'm going to give you guys a moment. I want you to find for me the vertical asymptote or asymptotes, the horizontal asymptotes and the x-intercepts of this function in either one of these two forms. They are the same. Tomorrow we're going to jump into the new lesson. We're not going to get ahead today. De-rankle your brains this evening. But I want you to find for me these 3 things. If you don't know how to do it, please don't just sit there and wait till they're on the board. I want you to find them. And if you're not sure how, ask, and I will help. Excuse me. Excuse me. All right. Vai. Go. Trabaja. Hey, all right. So, vertical asymptotes. I can see them. Can you? Where? What? What did you say, Kian? -1/2 and 7. Yay, nay. Horizontal asymptotes. Are you looking at the top or the bottom one? Original or? For horizontal, I would look at the top. What's the degree of the top?
1.
Degree of the bottom?
2.
The bottom's bigger. What's our horizontal asymptote? 0. Boom. X-intercepts. There's only one of them. When is the numerator 0? When x is -4 is when y is 0. From these 3, we're pretty close to being able to write this out. I'm going to make one more comment. How many times did -4 show up just now? 1. And is that 1 time, is that an odd number of times or an even? So this is that idea of multiplicity. It crosses the x-axis. Okay, from just this, I don't know that we even need any more points. We can graph it. How far out in the positive x direction do I need to go? At least to 7, but I'm always going to go a little bit further. I'm going to go to 10. How far in the negative x-axis? Try again. Try again. At least negative 4, because I need to see it, right? So I'm going to go like negative 6 to 10, maybe. So we'll maybe do negative 10 and 10. We'll see how it works out. Okay, for the y, I need 1/2 is the only one I'm guaranteed. So let's check it. X and y. And let's just pick our scale. I'm going to go to 10, which if that's 10, then this is what? 5? And this would be roughly negative 5, and that's all I'm going to put on it. Now, if we want a little better picture, we can. Like, we can go through the process and get some better y values if it would help make you guys feel better about them. There's a really, really, really easy y value we can use. What's the easiest x we can ever plug in? 0. So maybe it's not a bad idea to just get that x-intercept or the y-intercept as well. Help me out here real quick. What's f of 0? Would you plug it into the top or bottom function? Okay, 0 plus 4 is 4. Over 0 minus 7 is negative 7. Negative 4/7. Which means if I wanted to pick a nice scale, we can now. But I do know it's negative. So, I don't know, maybe that's negative 1. And that's a little bit more than half. There's my y-intercept. With just these points, we are so close to being able to graph it. I'm going to put the asymptotes on. So let's see, negative 1/2. Would you believe it if I said it's here? It's not perfect, but x equals negative 1/2. Where else do I need a vertical asymptote? At 7, it's all the way over here. Okay, I also have a horizontal asymptote, and I hate these ones when they're here. I'm going to put it on the axis just as a dashed line. And give me like 10 seconds and we can finish this. One more point that I have on my graph. There's one more point that I get on my graph. Not 7, it's undefined. Not 8. Negative 4, 0, right? So negative 4, 0 lives right here. Okay, I want you to finish this problem to the best of your ability tonight. Tomorrow at the start of class, we'll do this. We'll have a short quiz just showing, find me the asymptotes and stuff. Whether I won't make you graph tomorrow. We'll just say find the asymptotes and stuff because that's the hardest part. Cool. Finish this graph and knock those ones out. I'll see you cool cats tomorrow.